Hello, everyone. Thank you for coming today. We're going to start up in just a minute or two, let people show up. While we're waiting, if you haven't already checked out our workshop resources, these are going to be very important. We're going to use these to mainly create our two data sources for this project. So if you haven't checked that out, please do. And I'm gonna post the link here just in case. So we'll start up in just a few seconds. All right. So again, if you haven't checked out our resources doc, please do that. We're going to be using those quickly or very soon to set up two data sources. And I want to introduce myself. My name is Jim Moffitt. I'm a developer advocate at Tinybird. I've been working with the platform about a year now. I'm guessing that I met some of you at the Google Cloud Next event in Las Vegas a couple weeks ago, but also maybe at a Confluent Data in Motion event the week before last in Chicago. And if that's the case, welcome to the workshop I told you about in person. For me, this session is like revisiting my first 90 minutes with the platform, again, about a year ago, when I sat down and started ingesting weather data and building an API around it. And what came of that, I'll show you just to give you a preview of the things you can do with Tinybird. My background before Tinybird was in flood warning systems, so I worked a lot with weather data. And I knew a lot of different data sources that I could play with. So I sat down and started ingesting different data sources into Tinybird and came up with what ended up to be this Grafana dashboard. And what you can do with this thing is you can import or look at data from 175 different cities around the country, essentially the 175 most populated cities. I'm actually in the Denver area, so let's go look at Denver weather. I can tell you, even without looking at this, that it is extremely windy here today. I don't think there'll be any bike riding for me later, but anyway, here you can see the last 7 days of weather. I've been collecting this data for about a year now. In fact, you can see here that there's, I'm going to move this widget. There's over 8 million different data points here. This system is collecting data from these 175 cities every 10 minutes, and it's been running 24/7 since about a year ago. And I just got to say that if I can build a dashboard like this, and if I can, more importantly, build the data collection system under the hood, certainly you can do it as well. Since setting this up a year ago, it has not hiccuped once. The ingestion into Tinybird and the serving of this data via APIs has been pretty much without any hiccups. Just to give you a preview, so what this thing is doing is every time I refresh this, it's calling Tinybird and pulling in data. So you can do things like I can come here and say, you know what, I want to look at weather from February. And again, I have a year's worth of data here. And say I want to look at a month of data. So when I apply this time range, there it made a call to Tinybird, and I brought back 30 days worth of data. And you can see there's all different kinds of weather data collected here: temperature, humidity, wind speed, cloud cover, etc. I've also done some work with endpoints on Tinybird to look at outliers, any sensors that are out of bounds, things like that. I've also been collecting a historical record of the top 100 US temperatures this year. So this is a moving window. And now that I've collected more than a year of data, I'm looking forward to building in some features where I can compare today with a year ago today, for example. And as you browse to different cities, it gives you also the top temperatures for the city you selected. And just to give you a hint of how this works, if you're not familiar with Grafana, I'm going to go in and edit this widget, and you can see here I've set up a data source that's pointing at Tinybird, but this is the endpoint I'm hitting. It's called reports.json. And again, every time I exercise this front end, it's making a call, a fresh call. There's no caching here. It's making a fresh call to Tinybird to pull back the data. So anyway, onward. So let's talk about the workshop goals. First, the main goal is to explore and understand the fundamentals of Tinybird. And that is focused on gaining familiarity with the core Tinybird objects, be it data sources, pipes, nodes, materialized views, and API endpoints. And as we build this project today, we'll be stepping through all of these concepts and explaining what they are and actually using them. And that's really the point of this, is to be a hands-on experience. If you don't already have an account with Tinybird, you probably still have time to jump in and create one. You don't have to put in a credit card or anything, just your email. And if you are catching up here, you could set up an account in just a few minutes. So let's talk about some resources. I already mentioned this shared doc with different important pieces of information. One, we're going to be pulling in what we call a dimensional or fact table about some fictional companies, and that'll be via URL. We'll step into that in just a second. And then we're also going to be using a Kafka stream. We're going to be pulling in a simulated stream of real-time stock prices. And again, these are stock prices for fictional companies. I won't be helping with any stock tips today, but it's a good, general use case that we can build upon. Some other resources. I'll open up this one. We do have a main repository that's also included in the resource I just shared. It's called Zero to Tinybird. That's sort of a catch-all for all of this sort of Tinybird 101 type material. Today, we're focusing on Kafka streams, but we could easily be talking about ingesting data from PubSub or Amazon Kinesis, what have you. And then there's also a second repository. It's actually on my personal GitHub, but what it represents is simply the end state of what we're building today. And when you're building Tinybird projects, the convention is that there's a Tinybird directory. And in there, you have all the different sources that make up our project. In a minute, we're going to be building some data sources. And for example, just to show you what they look like under the hood, it's really just a text file. It encapsulates your schema. It talks about what kind of ClickHouse data engine we're using, things like that. And we'll return to this. But one point to take away from this is under the hood, as you build a Tinybird project, it's really these configuration files that define things like data sources, but also the endpoints that we're going to build. And the key thing there is that you can manage these resources as code. A lot of our customers will use things like GitHub, GitLab to manage these projects, to make changes. Obviously, it's something you want to manage carefully if you have something in production, and integrating with Git is a great way to help that. So onward, the topics we're going to talk about today. We're going to start with creating data sources. That's how every Tinybird project starts. You have some data that you want to work with. You have a Kafka stream. You have maybe dimensional data living out in BigQuery, maybe in Snowflake, maybe on S3. But your first step will be creating data sources. Once you have those created, you will build data analysis pipelines. We call them pipes. They reference these data sources. And as you'll see, we'll be using SQL to pull that data, to join the data, aggregate the data, filter the data, whatever type of analysis you need to do for your particular data set. We're going to provide an introduction to materialized views. They're very important, especially as your data sources grow in size. They're very important in terms of performance. And we'll walk through an example. We'll build something without a materialized view, then we'll return to it, convert it into a materialized view design, and we'll see how the performance drastically changes. And then finally, we're going to do a quick introduction into the Tinybird CLI. That's the command line interface. So, and I think in general, we probably won't use the whole 90 minutes today. We may, and definitely we can have a Q&A at the end. I'm flying solo here today, I think. So if you have questions, again, we should have time at the end of our content here to answer them. There's also a chat option. I can try to attend to that as we move through the workshop, but certainly we should have time at the end of our session. So before we jump in, let's revisit what Tinybird is and review what we're building today. So what is Tinybird? At its core, it's an OLAP database, and we use ClickHouse as our data layer. And that brings a lot of things to the table for us. And if I met you in person at these events, I'm sure I talked a lot about this, about how how ClickHouse, it enables us to just work with immense amounts of data with very performant queries. You can have billions of rows and still have queries that return in milliseconds. But also maybe as important on the connection side, with ClickHouse, we can just serve thousands and thousands of requests per second. And that traditionally is a bottleneck in a lot of database systems where, it's great at handling dozens, maybe 100 connections, but at some point it just starts to become a bottleneck. And with our design and our integration of ClickHouse, that really becomes a non-issue. We've had customers talk a lot about some Black Friday scenarios where customers are serving e-commerce type use cases where they're serving. We had one case where 20,000 requests per second. So as you build something, even as a hobbyist, it's great to know that as you scale up, there won't be any barriers there. It's a data platform for unifying data sources. That's sort of what we're going to do today. We're going to bring in a Kafka stream. We're also going to have a dimensional table. The dimensional table kind of just provides metadata for the companies that are streaming stock prices. But it's a classic example where you have a real-time stream, you have a fact table or a dimensional table, and you're using that to enrich, to enhance. Maybe your stream just, usually they're very concise, maybe a product ID, a session ID, a user ID. But when you want to display it, build dashboards, build APIs, you probably want to enhance it with other metadata. It's a data analysis platform. At its core, that's why people come to Tinybird. They have massive data sets, live streaming data sets, and they want to analyze it. And that's why we're here today. It's also a place to design and deploy API-based data products. The main output out of Tinybird are very high-performant, low-latency APIs. So if you're in the business of needing to share your data, and you want to do that via an API, maybe it's going to a web app, maybe you have a web or a mobile app, maybe you're feeding a dashboard. As we'll see today, you can exchange that data using APIs. Here's another view of what Tinybird is. This is sort of an event-driven architecture diagram. Basically, in my mind, this represents a stream. You have some data source that's emitting events into an event generator. If we're in the world of Kafka, you think of this event bus that knows and manages the different topics and events coming in, but it also is aware of who's listening and where it needs to serve the data. And then if you look at that purple box, Tinybird basically encapsulates and abstracts away these parts of an architecture-driven system. You have an event viewer or event listener, and as we'll see in a minute, we have a native connector. So you connect it to Kafka and you start listening for those events. Those get streamed to a real-time database. In this case, again, we're using ClickHouse as our data layer. With that becomes an SQL engine that we've built into our experience, into our developer experience, where, as you'll see, we're just building SQL to filter, aggregate, and join this data. And then what Tinybird brings to the table, all these systems have a publishing layer. And what we have today at Tinybird is an API layer where you're building API endpoints to share your data. So what will we build with today? Well, there's a lot of moving pieces here. We're going to bring in a dimensional table containing company metadata, the stock symbol, the company name, when it was created, what's economic sector it's in, things like that. We're also going to have a Kafka stream of company stock price data. That is today, it's hosted on Confluent Cloud. I've been using that to feed the data into this Kafka stream, and then we'll be using the Tinybird native Confluent stream connector to pull the data. Behind the scenes, I have a Python script generating this mock data. I have a collection of 83, kind of a random number, but 83 mock companies, and I'm emitting a stock price, a time series every 10 seconds. This data has been running on and off for quite a while now. I think I have a database of maybe 2 million stock prices. Not a huge amount, but definitely enough to prototype with. Of course, and we're going to be using Tinybird. Let's see. And also, we're going to be, especially if there's time at the end, I'll be exercising the API endpoints we create. I'll be using things like Postman to demonstrate how you can test and vet and help design the endpoints that you want to stand up. So this is a quick look of the type of data we're working with. Actually, I'll just show you the real thing. I have another Grafana dashboard, live stock data. So here, there's a drop-down list. Here's like the different stock symbols we can pick. They all have different patterns. Some of these are quite interesting. Again, these are fake companies, so don't run out and try to buy this one who seems to be perpetually increasing its stock price. Let's just look at a few others. But anyway, every time I click on this, again, I'm making a quick call to Tinybird to get the data. You can see how performant it is. The queries under the hood are probably taking just maybe 20, 30 milliseconds. And even as my data grows, there should not be much of an increase in latency at all. All right, so that's what we're building. As part of this, we're gonna build API endpoints to return stock price data. And provide an endpoint where a user could come in and look for a certain stock symbol of interest, maybe a time frame of interest. So we need an endpoint like that. We're going to provide endpoint query parameters for selecting the companies of interest, but also the time frame of interest. And that's one of the points today is as you design your endpoints, you can bake in what query parameters or think that your users are going to need to pull the data in the ways they want to. We're going to build an endpoint that serves hourly stats. So the max, the min, the average for each hour. And this is where we're going to use the materialized view. We're going to build one, just a raw endpoint that serves hourly stats. We'll check out its performance, but then we'll revisit that and implement it as a materialized view. And I think you'll have some aha moments about how just the processing data and most likely the query latency will go way down. Here's a visual, and this is actually straight from our user interface. So as you build these systems, as you import data sources, as you start building these things called pipes, you get this data flow view just baked into the product. In this case, like that join table, you can see how we're going to be feeding both tables into that. So now, creating data sources. This is where we begin the hands-on part of the workshop, the part we've been waiting for. So what I'm going to do here, I'm going to our website, tinybird.co. I'm going to sign in. If you have not set up an account before, this is your opportunity to create an account. Again, no credit cards. We have a free model that enables you to store 10 gigs of data on our platform and also make 1,000 API requests a day. So definitely generous enough to start prototyping. I'm going to log in. And it's bringing me to the last workspace that I worked with, but I want to create a new one. So when you get to this screen, you have different options. You can pick what region you want to work with. Here I'm set up to go to our Google region in the Western European region. I'm going to pick US East just because, but you can pick, you'll see here, we have Google regions and also 2 AWS regions as well. So I'm going to switch to US East. And now I'm going to go up and create a new workspace. And you have to give it a name. I'm going to call mine Kafka 2 Analytics, call it version 3. This is actually the third workshop like this I've given. First started back in February. So anyway, that's what I'm going to call my workspace. You can use underscores to delineate different terms in your workspace name. We have starter kits, one for web and log analytics. I want to start up with an empty workspace. And while you're at this stage, you can add in colleagues. Maybe you're building something with a colleague, you could add them at this point. So I'm going to create my workspace. So this is what a clean, unused workspace looks like. And again, we're gonna build 2 data sources. So for your first data source, go to the plus button by data project, and we want to create our first data source. And we're going to do a remote URL. This is the process where we're going to pull in a CSV that's hosted out on a GitHub repository. And again, if you go back to that starting doc, you'll find the URL there for creating the company info data source. So I'm going to copy that in. And you can do this with any hosted data source you know that you want to work with. In this case, again, we're bringing in a comma delimited values. I'm going to hit add. It inferred the name of my data source from the data file itself, and I'm quite happy with the company info name. I'm having it guess the schema, and I can see here that it did everything quite right. I don't really need to make any changes. And from my experience, I find that our auto-inferring of schemas is maybe 90% the way I would want them. You can go to advanced settings just to learn more about that. You can do sorting keys. These are very important. I think in general, most of my users are going to be using or searching for data by symbol, but also maybe name and maybe economic sector. I want to keep this data forever, but you can set a time to live. Like maybe you have a moving window and you only need to keep 7 days worth of data. That's a great way to sort of keep the amount stored of data quite low. I'm going to go ahead and create this data source. And there you see, just like that, I have this dimensional table. Like I said, it has the symbol, the name, the creation date, and the sector. So let's go and create our second data source. And this one will be obviously much more interesting. It's a live stream of data, and this is what you should be doing as well. Hit the plus button again, go to data source. And in this case, we're bringing in a data source from Confluent. And what I want to do here is go back to that starting doc. I want to pick out that Bootstrap server URL, put that in right there. I have a fresh key that I want to use. We should all be using the same key and secret. And then I'm going to go in and select my secret. And with any luck, this is like 90 minutes of live coding, so wish me luck. Hit next. Oh, good, it worked. So in this case, I just have a single, actually I've configured these keys to give access to a single topic. As a company, we have many topics flowing on this stream. But here I'm going to select the stock price events. It's the only topic made available, so make sure that one's selected. You have the option to bring in all the data ever published on this stream, which again is around, I think, 2 million plus stock prices. Or in some cases, you might want to come in and just start now. Like, I don't care about all the history. I'm building a fresh system. I don't need that history. You can pick latest. I want all the data. And here again, we have, it's inferred the schema that it's seeing on the stream. The key thing for me is this timestamp. It did parse it as a date time. That's exactly what I wanted. Everything else is pretty routine. I use these numeric IDs for these companies. They're integers, but another important detail is the price. They're floats. Obviously, prices have decimals. Let's go into advanced settings. Again, I want to set sorting keys. This is probably, in terms of query performance, one of the most important details. I know that I want to have users be able to sort by symbol. Also, they're going to be doing a lot of time searches. Maybe they want to look at a stock performance a year ago, what have you. Maybe they're doing some searching by price ranges. So I'll add in price. Again, you could set a time to live. Maybe you only need 90 days with this data. I want everything. I'm going to rename this to event stream. And these names here are important because we're about to build some queries based upon that name. We're going to be selecting X from event stream. So let's create this data source. And it may take a minute or two, but I got this good message down here that the data source was created successfully. I've already seen data come in, and now we have our two data sources. And from this moment, as my Python script is sending, as it's publishing events on the stream, they're essentially instantly showing up in this data source. So in just a few seconds, we are able to browse, select a topic, and now we have this live data flowing into our system. So now, now that we've moved through that, if I gave you a demo, I always try to stop at this point in the demo, and this is because this is sort of a good view of what native connectors we have today, and we're always adding new ones. In fact, we just added Red Panda, which is a Confluent compatible streaming protocol or system. But you can see here, there's flexible ways to pull in data from URLs and files. You can go to a raw, native Kafka, Confluent hosted Kafka, Red Panda's version of Kafka. We have BigQuery integration, Snowflake, and Amazon S3. And we're always interested in what different data sources you'd be interested in having us host natively. Do note that if you have data sources that don't live in any of these boxes, we do have this events API. And with that, you can basically stream data to us. I've had many projects. One, for example, was a PubSub type project where the data was being published there. I wrote a Python script to consume that data, turn around and stream it to Tinybird. So it's a very amazing API. It's very high performant. You can send in thousands of requests per second. Ideally, you can batch data and send it in, but if you have some system where you're just flinging in data one event at a time, it's pretty flexible in that sense. So now that we have our data sources, we can start working with them. And this is where sort of the joy of Tinybird comes in. What I'm going to do is first I'm going to go back to my new data source or my new workspace. And I'm going to show you sort of a relatively new feature. It's called the playground. So I'm going to go here and I'm going to create a new playground. I usually call my first playground ad hoc because I really have no idea the type of queries I'm going to build at this point, but I do know I want to explore the schema. I want to write some queries. Here I'm going to run this, and you can see I can return all the data from the company info. I'd rather work with our event stream just because there's so much more data there. One thing I want to do here is I want to take a count. I'm just curious how much data we actually have in that data source. So I'm going to do a from event stream. And I can see I have 2.5 million in that. And you can give these different names. I'm going to call that simply count. That's what it does. Let's show some other things you can do. And again, what we're using here is just standard SQL. You can use SQL to join, aggregate, filter your data. Let's build a filtering example. I'm going to call this one, let's call it something called filtering. And I'm going to say select. You can see here, one thing to mention before I move on is that it by default pulls data from the previous node or for the previous query that we have. That's just a really convenient convention in Tinybird because later when we're building our pipes, you'll see that you can break your query into pieces. You don't have to do a super complicated query in one go. You can kind of apply your logic one node at a time. So let's go here. I want to pull from the event stream again. And as you can see, you can just do classic SQL. I have a certain stock symbol in mind. I want to just pull that data. As you can see, all I got was that data from there. Even in the playground, it shows you how much processed data was required to return this. And you can see here is about 0.5 meg. But I can do things like, I want the symbol. You can obviously be more selective, and that's always a best practice. Don't pull back the whole table. We have a timestamp we want to bring, and we have a price. I want to make sure I can run that. You can see we went from 0.5 meg. We cut that in about 1/3. Another nice feature of our developer experience, our UI, is that when you're working on these queries, you can click on the data source, and you actually get the side view of its schema. You see recent data. You can go to this tab and see a list of how the schema is set up, etc. So there's a lot of cool features here. Let's do another node. Let's filter by time. I mean, that's obviously something that a lot of our users are doing, and certainly what we'll do today. Here, I want to close that. And let's do a filter by time. Again, you can see by default it pulled from the previous node, but I don't want to do that. I want to oh, actually, I do want to pull from that one. So I want to pull from the other one, which already filters on a company name. And now I'm going to do another where clause where the timestamp helps to spell everything right. I want to, when that's greater than add hours. And I want to do a now, reference to now, and I want to look back 2 hours. And I do want to, let's do an order by. I want to order by timestamp descending. And let's see if this works. Yep, I didn't fat finger anything. So here we're just looking at the last 2 hours of a certain stock symbol. And again, the way we selected the symbol is in a node before it, we selected on a symbol of interest, and then we built upon that by now filtering by timestamp. So anyway, that's a quick look at the playground. It's just a great tool for, especially when you first bring in a data set, you want to explore it. You want to, you can do finding the most recent data. You can make, you can check on things like how up to real time is it, things like that. All right, so onward. Now we're going to build data analysis pipelines, and we're going to start off with a filtering example. So again, now go to data project, and instead of building a new or importing a new data source, we want to build our first pipe. And I'm going to call this one filter. You can guess what we're going to demonstrate here. Let's build our first query, and I'm going to select everything. I should be more selective, and I will in a minute. We're going to do another where clause where the symbol again is equal to one of the stock symbols. I'm going to order by timestamp, and I want to do that descending. I'm very biased towards looking at the most recent data first. And let's do a limit by. So I'm bringing back the most recent 100 records or prices for this. Of course, again, I want to practice what I preach. I don't want to bring back everything. I want to bring back the timestamp. I want to bring back the symbol of what I'm pulling in, and I want to bring the price. So here helps to have a comma, not a period. But here again, and just like I could have done all this to get to this point in like a minute. Bring in that Kafka stream, confirm that the real-time data is flowing in, and then it's super easy to come out and build a pipe referencing that live data. And now we're gonna, having this simple pipe is great. It's filtering, it's doing some transformations on the data, namely most recent data first. But let's make it a little bit more universal. We don't want to hard code what symbol people are looking for. We'd rather have that as an option to select the company of choice. So I'm going to go back to the deck, and we're going to talk about our templating language. And this is where you can build in, using this templating, you can build into these queries, these query parameters that you want to provide your users. So they're used to build these dynamic query parameters, and they're used to affect things like what fields you're selecting. I'm going to be showing where we're going to be affecting the where clause, where the stock symbol is what the user selected, not hard-coded. But you also can use these things to affect order by, group by, and limit statements. And in its most basic form, it looks like this. Where you have the double curly braces to open the statement and double curly braces to end it. You specify the type of input you're receiving from the endpoint query parameters. You're giving it a name. In this case, we're showing a default of 100. So here is a step through. Here's the most basic form, actually, where I'm saying, hey, I'm setting up a query parameter for max results, and it's going to be an integer. Here I'm adding one detail where it has a default of 100. This is very important. You can add a description, because you'll see later as we publish these endpoints, it auto-generates documentation. And from where you add in these query parameters, you can add descriptions that show up in that documentation. You can specify whether it's required parameter or not. You might have some where the user must select or provide an option, and often, in most cases, you might have it required equals false. So let's go back and make some changes to our query here. So what I'm going to do is I'm going to rename this filter by symbol. And we're going to blend in our templating language. And I'm going to copy and paste something here. So here you can see we hard-coded symbol equals this ALG. And I'm going to copy and paste in this templating language to set this up. And what we're saying here is, if this thing called company is part of the URL query parameter coming in, if it's provided, I want that symbol to match what the user passed in. I gave it a description, etc. And one thing to keep in mind, this is a very common pattern, is the user often will not provide this company. So this if defined will not be true, and we won't add on to the where clause. So in those cases, we want to do something like where one, or even where one equals one, something that's always true. And the reason for this convention is, again, if they don't provide company, we need something in our where clause. So this one equals one is just one way of getting to that. I'm going to run this and just make sure it works. Yep. And you'll see here this message about a full scan. We'll talk more about this in a minute, but here it's saying, look, you scan the whole table. We suggest there's other ways you can not do that. Maybe you can fine tune the time frame you're looking for, but we brought back 50 megs here. Let's run that. And another thing to notice, now that we've added this templated query parameter, you can see up here that it's now, like, we parsed what you wrote. We know that there's this company option for a user to provide, and that is awesome. And then another thing I want to do is, let's see here. Now I'm going to do something else here. I'm going to create this endpoint. And again, this is sort of the magic of Tinybird. You've built this query, you've added in a dynamic query for selecting a symbol of choice. Then you just come up here and click this button. Often you're going to have many different nodes to choose from. In this case, we just have one. So I'm going to select that. And now we have this endpoint. You can share the docs. I can show that. Actually, let's click that. So one thing I love about this system is you can come in here and you could share this with colleagues, with customers of your APIs, what have you. But it's just a quick and easy way to auto-generate docs. Let's go back to our. Okay, so here we have another thing to see is as requests start coming into this, you have observability stats. You have how many requests have been coming in, how much data that was processed, what's the average duration of your queries, et cetera. And importantly, how many errors. Obviously, this is brand new. No one's hit it yet, so these are all zero. But as you start building the system, know that this is a key part of Tinybird in terms of understanding how your APIs, how your system is being used. So let's go create another pipe. We just built our first filtering pipe, but now we're going to build an aggregating pipe. This is probably a little bit more interesting and probably more common. I'm going to run this. I'm going to call this aggregate because that's exactly what we're going to be doing here. And let's build our query. This is probably one of the last queries I'm going to type out by hand because it'll be a little bit quicker to have me not typing everything from scratch. But let's build out this query. And this is where we're gonna first introduce some of the magic that ClickHouse actually brings to the table. ClickHouse, was built from the ground up to work with real-time streaming data. And with that, and because of that, they have built sort of a dialect of SQL that provides all kinds of time and date functions. And we're going to use one of our first ones to start of hour. And what this magically does is it will bin up all the data into hourly buckets. And if you've ever tried to do window temporal time binning in just raw SQL, you probably know very well how gnarly those queries can become. So this, just reflects some of the design that has been put into ClickHouse that we've inherited at Tinybird to help you work with time series data in an easier fashion. So I'm going to bring in the symbol. I want to take the average of the price, and I'm going to I'm going to alias that as price average. I want to bring in the min price for that hour, and let's call that. I'm a stickler for being case sensitive in my SQL. I'm going to do a min, and let's do a max. I want to do a max of the price as price max. And I want to bring in from the event stream. I need to group by. I'm grouping these by symbol. This kind of dictates these hourly buckets. So, I want to make these hourly buckets in reference to the symbol and for the time of that bucket. And then finally, let's do an order by clause. I want to do time. Let's see, I want to do it descending, but I want to bring back the symbols by an alphabetical order, so ascending. Let's run that. All right, so we have, let's name this, call it get stats. And here you see we have min and max, we have our average. There's something I can do here too. I can do a round. I just want to make that look a little bit more presentable. Maybe this is going to a dashboard. Let's see if I can do a round. Okay. And it's just another example of you're using standard SQL plus the dialect that ClickHouse provides. Another thing we want to do, I want to run that. And let's build another node on that one. I'm going to call this one endpoint. That's one of my conventions. It's a common convention at TinyBird and with our customers is, again, you could have many different nodes and you're only going to publish one of them as an API. Often you'll have one node feed another node, but you end up in this final node that I name endpoint. So when I go to select my nodes to publish, I know for sure which one I want to grab. So I'm going to copy in some SQL here and I'll talk through it. And what this one is going to be doing is it's selecting from our previous one, which I guess I called get stats. And there you can see how the syntax highlighter reflected the fact that, yes, now you are pulling from a data source. Here's the where 1 equals 1 convention, because I do add in that block again where I'm supporting a dynamic query parameter for selecting the company. And also I have here where people can say how many hours of data they want to return. So I'm going to run that. Oh, it's because I aliased that as just time in the previous. So let's try that. All right. So here we go. We have this node that, couple things. Now there's 2 parameters. I've included one where the user can select the company of interest, but also how many hours back they want to go. By default, it goes back and collects the last day of data, but you can obviously change that as a query parameter. And again, just to review, here's our templating syntax in action. And let's see here. Let's create this endpoint. I'm going to come here and select endpoint. And there we have it published. So, and you can also come in here and view API. What you see here, this is kind of a neat feature. One, again, you have your observability at the top. If we had requests coming in, these would be updated in real time. We have the available queries available. The available parameters. In this case, we have company and hours. But this sample usage is great. It shows you the form and the format of what data, JSON data is returned to the requester. We have some metadata at the end. But here's the data that we're returning. And you can do things like, you can just go to a new browser and copy in that URL with those request parameters, and you see what you got there. So this is just a live, as data comes in, this will always be reflected essentially instantly in the API results here. And I could do things like, look, I just want to get the last hour. And that's going to bring back, yep. And I can say, what else? I want to do company equal my favorite company, ALG. And don't have any data from the last hour, but you can see how dynamic it is to change the request that you're making. All right, so let's build one more pipe. And this is going to demonstrate how joining data works. And I'm going to call this one join data. Just obviously, it's very helpful to give your pipes names that you and your colleagues will understand what they do. But also, more importantly, as you publish these as endpoints, they inherit the endpoint name itself. What's in the URL inherits the name of the pipe. Again, if I go back to this one and I view the API, you're going to see here in the URL itself, we have filter.json. And while I'm here, it's worth mentioning, you can easily change the format and the data type that you're returning with your endpoints. For example, you could return all this data easily as a CSV, and you do that by just changing the what am I trying to say? The type here, filter.csv. You got NDJSON. That's another format we support out of the box, but also Parquet as well. So let's go back to our join data pipe, and I should also remind you, as we go through all this material, we do have these repositories available. And again, the convention is under Tinybird. You'll find all the resources used to build this project. Here in pipes, for example, you have the join data pipe. So what I'm going to do is I'm just going to build that. And you can do the same thing here. If you're following behind with the SQL that we're typing in, you can always find them here in these resources. So let's go back to let's build our first node here. And I just copy and pasted from that resource I just shared. But what we're showing here, let's call this explicit join. There's implicit and explicit joins. We're doing explicit here. So what we're doing here, and this is a classic work or a use case where you have a real-time stream coming from the event stream, but you also have a dimensional table, and you want to enrich this data. You want to blend in your dimensional data with your Kafka stream. So here we have, I'm going to reformat this a little bit. Here we're pulling in from the event stream the timestamp. We're going to the company info table and bringing in the symbol. We're also bringing in the name. Back from the stream, we're pulling in the current price. And here we're tacking on the sector of what sector that company lives in. We're doing a join from the company info. So here at the left join is referencing our smaller table. We're joining that with the event stream. And these two tables, these two data sources share this common attribute called symbol, and that's what we're joining on. And we're doing our traditional bring back the most recent data. And there you have our join data. We're showing the real-time stream. This data point just came in a few seconds ago, but I'm mashing it up. I'm enriching the data that stream provides with things like the company name, what sector it's in, etc. So a very classic example of joining data and why a lot of folks use Tinybird to blend, to unify their data sources. If I go back here, I was just going to show one other. This is what I guess I'll call this implicit join. This form, oops, I didn't want to do that. I want to call this. And this is not really a recommended way to do joins, but just to show that it's flexible. The reason this isn't best practice is because you don't have any control over what's the right or the left join. But here's just another form. And this just goes to show how we're very flexible in this type of syntax you use. If you can write it in SQL, you should be good to go. Now, let's go back to our deck. I just want to catch up there. Yes, we're now going to introduce Materialized Views. And Materialized Views are very important. Again, they're really a performance tool. And as your data sources grow and grow, Materialized Views become more important. And one thing key about them is that the data is processed and transformed, filtered, aggregated, what have you, as it arrives and not when it's queried. So if you have some aggregation, like we've already built one for hourly data, imagine you have thousands of customers who want to pull that data. Rather than serving up and aggregating that data on the fly when it's queried, we aggregate that data as the data first comes into Tinybird. We essentially do it once and then serve it as many times as needed. So you use Materialized Views. They're very handy when you're building these aggregations, when you're building summaries and views as data comes in. And as the data source grows in size, these become more and more important for performance. And Materialized Views consist of two things. First, we have a transformation pipe that writes to a new data source. Commonly, we use what we call the state operations, and you'll see these in action in just a minute. But basically, what we're doing is data arrives, we're pushing in temporary state data representing that data. And then later in the materialized process, all those different chunks of new data are merged with the data that's already been processed. The second thing a materialized view consists of is a data source that maintains those intermediate states for new data along with the existing data. And then finally, you build these materialized views to consume that process data in a more performant way. So when you build materialized views, you will build consuming pipes that read from that data source. And commonly, you build queries that trigger this merge operation. So another view of what a materialized view is. We'll talk through this. Every time data is ingested into the data source, you end up in a state where you have data that's already existing, that's already been aggregated, maybe into hourly buckets, maybe daily buckets, what have you. But then you have these intermediate temporary states of that data that's arriving as well. And then the materialization process, what it's doing is it's taking that previously transformed data and blending it, merging it with the latest data that's come in. So what it means is rather than going through all the data that's ever been ingested, it already has a chunk that's already been processed, doesn't have to be touched again, and then blending in these new, freshly arrived pieces of data. So here's a view where, you have this materialized view that consists of data that's already been aggregated. In this case, looks like we're counting how many objects are A, how many objects are B. Meanwhile, we've had new data arrive, maybe in just the last few seconds, milliseconds of new data. And then you trigger on the consumption side, you're saying, hey, I want this type of data, I want those hourly stats. It triggers a merge. It at that moment blends all that data together, merges it, and gives you the final answer. All right, so we're gonna go back into our project. Just a couple of things I want to do here. One is here again. We see what we're processing here. We're doing a full table scan. In this case, we're processing 50 megs of data, and it's taking 26 milliseconds. So what we want to do now is we're going to convert this. We're going to build a materialized view instead. And here, let me bring up something on my side. All right, so let's create a new pipe. And I'm going to give it a name like feed hourly materialized view, which again kind of gives me a hint of what we're going to build here. Again, this is the first piece. This is the transformation pipe that we're going to feed a brand new data source with. So I'm going to copy in. You're going to recognize this query I'm about to click in or write in. It's what we had before. And again, what we're doing here is we're using the ClickHouse function to start of hour to blend all to get the data into hourly time buckets. We're pulling the symbol, but we're also doing the average, min, and the max. And so what we're going to do now is in the process of building this materialized view, we're going to do a couple things. One is I mentioned earlier in the slide where there's a set of function called state functions. And what I'm doing here is I'm just these aggregate functions, average, min, and max. I'm telling the underlying instance of ClickHouse that we're sending in different intermediate states into a table. So, and while I'm at it, I'm going to add in standard deviation just because they have a great function for that. And when you're working with these type of stats, obviously it's nice to have things like standard deviation at your fingertips. And I'm going to alias that standard deviation. We don't need to do any ordering here because, again, this materialized view that we're building, it's really just a new data source. We're not directly displaying data from this data source. We don't need to worry about how it's presented to the user because the pipe that we build to pull data from this materialized view will do that type of work. So let's see if that works. Okay. All right. And I'm going to, you'll notice here too, this data looks kind of strange, but in my mind that shows me that it's working because under the hood in ClickHouse, we're storing the new intermediate states that have just arrived as binary data. And when we pull the merge, it'll do all the work of merging that data. And by, under the hood, keeping it as binary data just makes everything performant and fast. So what we're going to do here, I'm going to rename this one. I'm going to call it feed the materialized view with state. And so it doesn't really matter, but I'm going to be a stickler for my case of how I name these things. So here we have this transformation pipe. It's doing our aggregates. It's doing our average, min, and max. It's using the state operator, telling ClickHouse that we're going to be storing intermediate states as data shows up. And then here you go to the node we just set up called feed MV with state. And instead of publishing an API endpoint, I'm going to create a materialized view. And again, I can give it any name I want. Let's see, I'm just going to name it hourly stats. Hourly stats. And I'm going to mark it. My convention is to mark it with MV, just so when I'm reviewing my data sources, I know which one is the product of a materialized view. What else? It has the sorting keys already set up. I'm happy with those. I'm happy with all that. So let's go to next. Again, I want all the data I have. By default, it brings in the last 2 million rows. I have 2.5, so I might as well just say, hey, bring in everything, previous and new data. And when I click this, some magic happens. You're going to notice that I have this hourly stats materialized view data source. And now let's go back and build a new pipe. We now, we've taken the 2 steps. We created a transformation pipe, which in our case just does these simple aggregates, these simple statistics. And then we took that node, that pipe, and we fed it into to create a new data source called hourly stats. So let's build our third piece. This is going to be the pipe that's going to pull from that data source. And I'm going to call this one just simply hourly stats. And I'm going to call this first node merge from NV, which again is basically illustrating what we're about to do. I'm going to bring in some SQL here and I'll talk through it. But what we're doing here is we're pulling in the timestamp and the symbol. You can see that we're pulling from the hourly stats materialized view. And while we're doing that, we're bringing in the merged version. We're asking for the merging of the existing data that's in that data source plus any of the newer ones that have just arrived as intermediate states. And we're merging them for both the average, but also for the min and for the max. And if I run this, again, I've been switching up how I talk about my timestamp. I guess earlier I aliased it as time. Let's make that change. And I think that should be good. All right, so there we have our final view of these aggregates. It's done the work of merging the data. And one key thing to note is if I go back to aggregate again, here we're not doing any materialization. We're just pulling and working with the raw table. It was processing 50 megabytes per request, taking about 17 milliseconds. But now when I come to this materialized view version, you'll see, actually I want to go back, and if I rerun this, oh, wrong one, hourly stats. If I run this, you'll see we went from 50 megs to now we're well under a meg, well, right about 1 megabyte. So we reduced the amount of processing needed by a factor of 50. And we went from like 17 to 20 milliseconds down to 7 milliseconds. So that in itself sort of encapsulates the value of materialized views. And again, they're by just doing all these aggregates as data comes in and serving those results as queries arrive, as API requests come in, it just makes things much more efficient. All right, so just in a review, like in this session so far, we've accomplished a lot of things. We've created 2 data sources. We showed examples of aggregating the data, filtering the data, joining the data. But maybe more importantly, we also built a materialized view to serve things like hourly aggregates in a very efficient way. Now, you can imagine if you had a data source with billions of rows, the dramatic increase in performance would be even higher with a data source that big. Now let's talk more about the Tinybird CLI. Now, I'm very proud of the developer experience, the UI that we've built. I find it sort of a joy to work with. But obviously, it's important in many use cases to have a CLI where you can work directly with the platform. Maybe you're automating things. Maybe you have some process where you're pulling stats from a certain workspace. You're pulling information about how many queries have been made, what its average performance is. Well, you can do a lot of this with the CLI. So what I'm going to do is I'm going to stop my sharing of the screen. I'm going to switch gears to a terminal. So I'm going to stop my screen share, and so I can see my screen. I'm going to share part of my screen again. So here we go. So the first thing to do with this is we're gonna do a Python virtual environment. And hang on a second. I got a little recipe written here. All right, so just for best practice, let's load up a Python virtual environment, Python 3 in my case, and I'm going to call it temp project. And then I'm going to source that project. And what I'm showing here is how to install the CLI. And then, so now we've got this Python environment set up, virtual environment. And to install the CLI, it's really simple. In my case, my environment, I have pip3. Yours just might be pip. I'm going to install, and then it's called tinybird-CLI for obvious reasons. And it's basically telling me that I already had all this all set up. But in your case, it's going to go, the script will go a little bit longer as it installs it. The first thing you do once you have this, and you can confirm everything is set up right. You can do like a TB for tinybird --help. And you see, and what you're going to notice here is we have different sets of commands that sort of map to the different basic objects of Tinybird. There's commands for the data source. There's demands for the workspace. There's the commands for working with pipes, etc. And I'm going to do, the first thing you usually want to do is authenticate. So what I'm doing here is I'm going back. Oh, I should switch back to my, this is kind of an important step. I'm going to go back to my workspace, and you can follow along with this as well. What I'm going to do is here I am in my workspace, and you'll notice there's a tokens hive here. And this is where you can manage, as you deploy these endpoints, you can fine tune requesters and what access they have. You can make, obviously most of these endpoints are going to be categorically read only. In my case, I want to work with the CLI directly. I'm going to pick out my admin token here. It's associated with my email. I'm going to copy that. And now I'm going to go back to my command prompt. So I'm doing a TB auth, and then I'm going to hit return, and then I'm going to paste in that token I just grabbed, and I've now successfully authenticated with my workspace. And with that, you can do things like I want to do a TB workspace, and again, I'm on the Google Cloud for Eastern United States. I can go confirm what workspaces I have there. I can do a LS, and it tells me I have 1, 2, 3, 4, 5, 6 different workspaces set up there. The top one is the one we're currently working with. Another thing you can do, say you're jumping around different workspaces, or maybe you have a script where you want to automate which workspace you want to work with. I could do something like workspace. I can see which one is my current one. And here I confirm that my current workspace is the one that we've been working with. That's all well and good. Now that you can select the workspace you want to work with. I can do things like TB data source LS. And here it shows the 3 different data sources that we've set up. We have our company info, dimensional table. We have our event stream, and there you can see in the results that it's saying that, hey, this is connected to a Kafka stream. And of course, we have the 3rd data source we've just set up, hourly stats. But anyway, there's all different kinds of things you can do with the CLI. And again, if you're in the business of automating things, like maybe you're automating the creation, maybe you're cloning a workspace and you want to go through the steps of automating the creation of that workspace based upon templates you already have, the CLI will be your friend there. It's got things like, I can do things like, I want to pull all the resources I have set up in this currently used workspace. I want to pull all those resources to my local machine. I can say, I want you to auto arrange them in different subfolders. And maybe I already did this, but I want to force the overwriting of everything I have local for what's currently live in my TinyBird workspace. You can do things like this. And if I now do, I can go into, I'm looking for, so I can go into data. I should have organized this in a better way before I pulled everything. But I go in my data sources. It's data sources, plural. And then I can see these 3 resources I just pulled down from our live workspace that we've been working with. Another thing I can do here is I can open up this folder, for example, and just remind you that you can click on these files, and under the hood, again, they're just configuration files, basically. I just opened up, you can't see it. I'm used to using a different presenting software. But bottom line is, if you open up these files, you'll see that they're just configuration files under the hood. You can manage them as code as you need to. All right, so I'm going to now switch back to my workspace, and we'll continue on. We have 15 minutes left, so I've actually used up most of the time. We definitely have time for questions, but let me show a few more things. Here, I'm going to go back to our workspace. Another thing here, let's go back to this. Yeah, it's probably worth showing, these endpoints that we've already published are just like any other endpoint that are out there. I can do things like, here I'm using Postman, and here again, you can see I've set up a company request parameter and also max results, so I can send that. The way you do set this up in things like Postman's, I go to the top here and there's authentication. I'm basically submitting a bearer token, and this is my admin key that I grabbed from my workspace. But once you have that set up, I have all these just to inherit from the parent. But once you have all that set up, you can just go to town. You can you can say, hey, I don't want to use that parameter. Let's pick out this stock symbol. I can go back here and change that. Anyway, it's a great way to kind of get a feel for how your endpoints are behaving, how they're acting, get ideas on how you envision your users using these. Here's hourly stats again, same type thing. I have the same type of request parameters set up. Here I'm looking at our hourly aggregates. In the final version of this project, I also have an endpoint that we didn't go through today, but it's called Get Prices. And it would be a way to also implement time boxing. You could have a min time and an end time, things like that. Here's the most recent, another endpoint that we didn't go through today, but if in many cases you just want the most recent stock price, I can turn off that request parameter to pull back every sticker price. And here you can see they're all created just a few seconds ago. So that's all good. Another thing I want to show is on May 21st, I'm giving another workshop on building real-time anomaly detection systems. If you go to our tinybird.co/docs/live, you'll find a link there to sign up for that. And what we're going to do there is we're going to explore different ways you can build anomaly detection methods into Tinybird. I mean, Tinybird already gives you that real-time platform to do this real-time analysis. And often the analysis you want to do, at least as a starting point, is anomaly detection. You want to know, maybe you have a set of 1,000 sensors. You want to know instantly if one of those sensors has stopped reporting on the interval you expect. Maybe you're doing simple things like looking for out of bounds type events being sent in. Maybe it's a rate of change. You're looking at a stock price and you want to know if any stock price has gone X amount in 10 minutes. You could build anomaly detection like that. But it will also explore things like using more sophisticated statistics like z-scores and interquartile ranges. And the beautiful thing is you can implement these things in SQL, meaning you can trigger these anomaly detections in real time, regardless of the scale of data that you're bringing in. And in this session, what we're going to do is I'm going to work with that weather API that I built. I refer to it as a weather data monitoring system. And I'm going to take that existing project and graft in using some basic recipes we'll discuss. And I'll demonstrate how I can build an anomaly detection system for my weather data. So anyway, really looking forward to that. Sign up if you can. It's only going to be an hour long, so it's a little shorter than this one. Another thing for next steps, again, there's this repository, 0 to Tinybird. The key thing there, a couple things. One is, here I'm looking at that. I have the data generator I'm using. It's just a simple Python script, stockpricestream.python. It's pretty primitive, but it does demonstrate how you can write to a Confluent stream. In this case, it does all the work of managing, not only creating new mock time series prices, but publishing them to Confluent. Another thing in this project repository, of course, is again the Tinybird folder. Here you have the data sources that we ended up creating today, but maybe more importantly, in these files are all the different SQL that we used. For example, here, if you go to feed hourly MV, you can see this is what we built today. We're using those state operations. And on the flip side of that, you can go to the hourly stats. You can see how we then triggered the merge operations to get the final version of the materialized view. So anyway, that is, I think, all we have for today. I am going to jump over and check the comments. I haven't seen any, but I think we're good there. And again, thanks for coming today. I hope you have seen and learned more about the basics of Tinybird, creating data sources, building these pipes of SQL. If you have situations where you're doing aggregates and other transformations and you're working with tons and tons of data, how Materialized Views can help you make that more performant. I think a next step, if you have your hands and the keys to different data sources, again, it's super easy to bring that data in the Tinybird. And while you're basically working in the UI, you can just go to town and build different transformation pipes. You can do all kinds of practice SQL to explore that data. If you get into or have questions, know that we have a Slack community as well. We spend a lot of time looking for questions there. tinybird.co/docs.community is a place to find a portal into that. And I think that is all the questions I had for today. So thank you all again, and we'll see you next time. If you have colleagues who you think may benefit from a session like this, we'll most likely be doing this again sometime in June. But again, on May 21st, we will have this session on building anomaly detection systems. And I'm looking forward to that one as well. All right. Thanks, everybody. Have a good rest of your day.